The National Electrical Code, or NEC, Section 330.17 governs the installation of metal-clad, or MC, cables. There is sometimes confusion regarding the requirements for running these cables through holes in metal studs. The code reference provided in 330.17, specifically its reference to 300.4a, is incorrect. Section 300.4 deals with bored holes in wood members, which is not applicable to metal studs. The correct reference should be 300.4b, which specifically addresses the protection of cables and raceways through metal members. Section 300.4b mandates that when installing cables or raceways through metal framing members, the installation must ensure that the cable or raceway is protected from physical damage. One way to achieve this protection is by maintaining a specific distance between the edge of the hole and the edge of the metal member. This required spacing is not less than 1.25 inches. This requirement implies that when MC cables are installed through punched holes in metal studs, specifically in your case, 1/5/8-inch metal studs, you must adhere to this spacing rule. The edge of the hole where the MC cable passes through must be at least 1.25 inches away from the nearest edge of the metal stud. The purpose of this spacing is to prevent the screws or nails used for attaching wallboard or other finishing materials from penetrating the cable. If the cable is too close to the edge of the stud, there is a higher risk of screws or nails accidentally piercing the cable's jacket and potentially damaging the conductors inside, leading to a short circuit, ground fault, or other electrical hazards. Therefore, strict adherence to this spacing is crucial for electrical safety and code compliance. In practical terms, this requirement means that you might need to carefully consider the placement of the punched holes in the metal studs. If the pre-punched holes are too close to the edge of the stud, you may need to create new holes or use alternative methods to ensure the required spacing is maintained. Some common methods to comply with 300.4b include using grommets or bushings to protect the cable from abrasion where it passes through the metal stud. Alternatively, you can install a metal sleeve or a protective plate to shield the cable from potential damage. Another approach is to use cable supports or ties to secure the cable in a way that prevents it from coming into contact with sharp edges or abrasive surfaces. When working with MC cable, it's important to remember that the cable's jacket provides a degree of mechanical protection to the conductors inside. However, this protection is not unlimited, and the cable can still be damaged by sharp objects or excessive force. Therefore, it's essential to handle MC cable with care during installation and to take precautions to prevent it from being damaged. Here are some additional considerations when installing the MC cable through metal studs. Firstly, always inspect the MC cable for any signs of damage before installation. If the cable's jacket is cut, torn, or otherwise damaged, it should not be used. Secondly, when cutting MC cable to length, use a proper cable cutter to avoid damaging the conductors inside. Avoid using tools that can crush or deform the cable's jacket. Thirdly, when stripping the outer jacket of MC cable, be careful not to nick or damage the insulation of the conductors. Use a cable stripper that is designed for MC cable to ensure a clean and safe cut. Fourthly, when connecting MC cable to electrical boxes or equipment, use appropriate connectors that are designed for MC cable. These connectors will provide a secure and reliable connection and will also protect the cable from damage. Fifthly, always follow the manufacturer's instructions when installing MC cable and connectors. The manufacturer's instructions will provide detailed information on the proper installation techniques and will help to ensure a safe and compliant installation. Sixthly, be aware of other trades working in the area and take steps to protect the MC cable from damage. For example, if plumbers are working nearby, make sure that they don't accidentally damage the cable while soldering pipes. Seventhly, after the installation is complete, thoroughly inspect the MC cable to ensure that it is properly supported and protected. Look for any signs of damage or potential hazards and take steps to correct them. Eighthly, when penetrating a fire-rated assembly, fire-stopping methods must be employed to maintain the fire resistance rating of the assembly. It is important to use listed products and methods for fire-stopping electrical penetrations. The products will be tested to ensure they prevent the spread of fire and smoke through the opening. Ninthly, when installing MC cable in damp or wet locations, use MC cable that is listed for use in those locations. This type of MC cable has a moisture-resistant jacket that will protect the conductors from corrosion. And tenthly, always consult with a qualified electrical inspector to ensure that your MC cable installation complies with all applicable codes and regulations. An electrical inspector can provide valuable guidance and can help you to avoid costly mistakes. It's also worth noting that some local jurisdictions may have additional requirements or interpretations of the NEC that you need to be aware of. Therefore, it's always a good idea to check with your local building department or electrical inspector to confirm the specific requirements in your area. In summary, when installing MC cables through metal studs, remember that the correct NEC reference is 300.4b, which requires a minimum spacing of 1.25 inches from the edge of the hole to the edge of the metal member. Adhering to this requirement is crucial for electrical safety and code compliance. Always take precautions to protect the cable from damage and consult with a qualified electrical inspector if you have any questions or concerns. Consider these points when working with MC cable. Firstly, understanding the NEC section 300.4b is critical for safe and compliant electrical installations in commercial and residential buildings. It outlines specific requirements for protecting cables and raceways that pass through metal framing members, like metal studs. The main goal is to prevent physical damage to the cables, which could lead to electrical hazards. Secondly, the 1.25-inch spacing rule is the core of 300.4b. It mandates that any hole bored or punched in a metal stud for cable passage must be at least 1.25 inches away from the nearest edge of the stud. This spacing acts as a buffer, minimizing the risk of screws or nails used for attaching wallboard or other finishes from accidentally penetrating the cable. Thirdly, alternative protection methods are available if achieving the 1.25-inch spacing is impractical due to structural constraints or pre-existing hole placements. NEC 300.4b allows for alternative protection methods like installing a steel plate or sleeve to shield the cable from potential damage. The protection needs to be robust enough to prevent screws or nails from contacting the cable. Fourthly, acceptable methods of protection need to be carefully chosen. When using alternative protection methods, ensure they are robust and properly installed. A thin metal plate might not offer sufficient protection against a screw driven with force. The chosen method should provide a solid barrier between the cable and any potential source of damage. Fifthly, the importance of grommets and bushings cannot be overstated. When cables pass through holes in metal studs, the edges of the holes can be sharp and abrasive. Installing grommets or bushings in the holes creates a smooth, protective surface, preventing the cable's insulation from being worn away over time due to vibration or movement. Sixthly, securing the cable is essential. Cables should be properly secured to the studs to prevent them from sagging or coming into contact with sharp edges. Cable ties, straps, or other approved supports should be used to maintain the cable's position and prevent strain on the connections. Seventhly, consider the type of MC cable used. Different types of MC cable exist for specific applications. For example, MC cable with a green grounding conductor is required for certain circuits. Ensure the correct type of MC cable is selected for the intended use and that it is rated for the environmental conditions such as wet or damp locations. Eighthly, proper connector usage is important. When connecting MC cable to electrical boxes or equipment, use connectors specifically designed for MC cable. These connectors provide a secure and grounding connection, ensuring electrical safety. Ninthly, inspection is critical. After installation, thoroughly inspect the cable run to ensure it complies with all requirements. Check for proper spacing, secure connections, and adequate protection against physical damage. Any deficiencies should be corrected immediately. And finally, consulting with a qualified electrician is always recommended when unsure about any aspect of electrical installation. Electricians have the knowledge and experience to ensure the work is performed safely and in compliance with all applicable codes. Following these guidelines will help ensure safe and code-compliant MC cable installations in metal stud walls. This protects not only the electrical system but also the building occupants.